Good morning. Today we will continue the fourth unit. In last video we seen about NDT testing, non-destructive testing purpose. What are different methods available non-destructive testing? What is the advantage and disadvantage we seen. Today we will continue with that and we will see about rebound hammer test, skimmed hammer test. It is also called as skimmed hammer test. So, rebound hammer test is a non-destructive testing which is mainly involved to find the surface oddness, and indirectly we can find the compressive strength of the concrete. A IS code also solely related to this rebound hammer test IS 13311 part 2 1992. Okay, it deals about the rebound hammer test and what is the table we have to follow to assess the quality of the concrete based on the results available or got from this test. So the main objective of rebound hammer test is to relatively determine the compressive strength. See, no NDT test can exactly find the compressive strength, because the exact method is that we have to take a core, okay, or whatever is done by a destructive test. So this and all is like a parameter, okay, or okay, we are following some means of measurement to assess what will be the quality. Okay, so it won't give the exact value, so it will indirectly find its compressive strength based on the rebound hammer number. And also we can find whether the concrete is uniform or not, and next one, the quality of concrete is assessed, and also we can compare one concrete strength to another concrete strength. For example, we can compare the strength of this column with this slab and with beam, what strength it has achieved. Okay, so indirectly we can find out this one. Okay, and regarding the parts of this rebound hammer, so the parts of, so this is an cross section of an rebound hammer. Here you can see a plunger is there, which will be always somewhat protruded out of the machine. Okay, if you just cut it means a cross section of this means we can find a spring, a hammer, a latch, the overall body, and an indicator. Okay, like it is visually seen here. So these are all the parts of the rebound hammer. So we will see the working principle of that. So generally, okay, you know the concept of rebound. Okay, rebound means whenever any material hits any surface, it will try to rebound. Okay, equal in that Newton third law, equal and opposite reaction. So you consider a ball. Okay, suppose if you just hit that ball on an soil, a ground, okay, which is made up of soil and a concrete surface, or you consider a rock, okay, where the rebound energy will be more. Suppose if you hit a soil or a ground, means what will happen, the rebound will be somewhat less. If we are hitting it with same force we are okay, just hitting that ball on a concrete surface, the rebound will be somewhat more. Why? Mean the concrete is somewhat harder, okay, when compared to the soil. So with this basic principle we can apply to the concrete surface. So whether the concrete is weaker means the rebound nature will be less, and the concrete is stronger means the rebound will be more. Okay, so in previous slide we seen about the hammer which is attached with the springs. Okay, so what the mechanism is that, okay, so here you can see that hammer, the plunger is directly connected to the hammer, and springs are placed at the, okay, in front of the hammer as well as the back of the hammer. So what we have to do means initially we have to release the springs, so thereby the hammer will try to come down, okay, and the plunger will be projected outside. Okay, if you have to place it on the concrete surface, okay, and if we just press it means all this okay, springs will, the topmost spring which is okay, head of the hammer will try to compress, okay, and the bottom one will try to, okay, get the bottom one will get the tension, the top spring will get the compression, and then the hammer will be locked, okay, in the top latch what it is provided. Okay, there will be a release button will be there. Once you press that release button, this hammer will be released from that latch, and it will try to, okay, hit the plunger, and this plunger is directly connected to a concrete surface means based on the strength, of that concrete surface, this hammer will try to rebound. Okay, so if it is a odd or strong concrete means the rebound nature will be okay more. If it is a weak concrete means the rebound of this hammer will be less. So with this we can indirectly find out its strength and the quality of concrete. Okay, this also another picture, okay, which clearly show the working mechanism of this rebound hammer. Okay, so mainly the hammer and the springs connected to that plays a major role. Okay, so this also another working mechanism. Okay, 3D view. Okay, how the rebound hammer number is calculated. Okay, next regarding the position for rebound hammer test. So there are three different position we can use the rebound hammer for testing the concrete quality. So one is by placing horizontally. One is okay, sorry. One is placing horizontally, like we can do it for a column. Here you can see this picture of that. One doing vertically up, another one is vertically down. Suppose if you are doing on a slab, okay, a floor. Slab means you have to do vertically down. This concept will come. Suppose if you are doing on a ceiling, then it will be vertically up. So with this, okay, we can find out different ways of reading. Okay, why means the concept of gravity. So here the, okay, if we see this one, okay, from upward down, due to the gravity the hammer rebound will be somewhat less. Suppose if we are doing on a ceiling, okay, due to the weight of the gravity the rebound number will be more. Okay, so when compared is to the horizontal, the gravity is, okay, almost less influence onto the rebound value. So there is a different scenarios are there, three different scenarios are there. So based on that, okay, we can make a correlation with the compressive strength. Okay, for this three, one, okay, is vertically up, down, and it is horizontally. So one is for wet condition, another one is for dry condition, because wet condition means the porous nature will be filled with some water, so there the reading will somewhat change when compared to the dry condition. So based on the, okay, number of experiments carried out, they formed a, okay, graph in which the x-axis will be the rebound number and y-axis will be the compressive strength. Okay, and with this line we can predict, suppose if the rebound hammer is 30, I'm doing vertically up, for that what is the compressive strength. Okay, so like that I can indirectly find its compressive strength. Okay, this is also another important table to assess the quality. The previous chart we can use to find the indirect compressive strength. Here you can see, as I told, if the rebound number value is higher means it tells the concrete is stronger. That means very good odd layer. Suppose if it is between 30 and 40 means it is a good layer. 20 and 30 means it is somewhat fair. Okay, less than 20 means it's a poor concrete. That means if the rebound is very less means what I told, it is an weaker material, so it is called as poor concrete. Sometimes if the rebound is not at all happening, the hammer is not rebounding, that means a huge, okay, air gap is there beneath the layer of the concrete surface where you have tested it. So that case what we can consider it as delaminated. Okay, and when we are doing the experiment, okay, minimum of some 9 readings is required. So on the surface of concrete we have to make the box like this, and we have to take an average of some 6 or 9 readings to confirm the result, because it is a point test. So the we can't able to identify the full entire surface of concrete. Suppose you consider a column, surface area is more. So for that case, to eradicate that problem, we have to do number of tests to confirm the test. And regarding the advantage, actually this apparatus is very easy. Okay, we can, okay, any person can use it because it is light in weight, and also there is no much complicated readings are involved in that. Okay, if you just do the test, the, okay, indicator will show the rebound number value, and also it determines the uniformity property. Uniformity property means wherever I test it, okay, it will tell that the concrete is uniform or not. And also this equipment is inexpensive, so the cost, okay, when compared with an compressor testing machine which is there in the lab, okay, it is comparatively it is very less. And also, in case of the old monuments or any ancient temples, if you want to do a stability check, we have to know its quality. Okay, for that, if you do a destructive test means we have to extract a core, okay, from that monument, so which many peoples or religious people won't accept, okay, or it will raise a big issue. So in that case, okay, in order to eradicate, okay, the removal of a specimen from that monument, we can do this type of rebound diameter test without disturbing or without extracting and core from that sample, from that temple. Okay, and regarding the disadvantages, as I told, that plunger dia will be small, so it will give a local point surface hardness only. So for that only I told, okay, we have to make some grid pattern, okay, and each and every, okay, grid we have to conduct the test, and then the average of that we should take it. And moreover, okay, it is not, as I told in the starting itself, it is not directly telling the compressive strength, okay, it is not giving a direct value. And next one, okay, it involves in springs. Okay, so suppose if you use the equipment continuously for more than 1 and 2 years, the stiffness of the spring will be reduced. Okay, so in that case also we won't get an accurate value. And last one, if any defects, okay, is there inside the concrete, okay, we can't able to detect it accurately. Okay, so these are all the disadvantage in it. And regarding the factors, the major factors affect is that the type of aggregate, cement, and the moisture, wet and dry condition, and also the curing and the age of concrete and carbonation. Okay, so all these factors will affect the rebound diamond number. So in next class we'll see about ultrasonic pulse velocity test. Thank you.